we did convert the method string from the request into a method enum. Now we have to separate the query string from the path, because we see that we get them as this single string, and we have to actually explode this string on the first question mark, and then the first part before the question mark would be the path, and everything after that would be the query string. If we look at the request definition, we see that we define the query string as optional because the request might not have a query string. This would still be valid. So first, let's just define the query string as a mutable variable. And let's say that it is none. We begin with the assumption that we don't have a query string. Now we have to discover the first question mark in our string. The string slice has a method called find that does exactly that. So if we just call path.find, and if we see what find does, it will return the index of the first character of this string slice that matches the pattern that we pass. And this pattern can be anything. So in our case, let's make it the question mark character. All right. The find actually returns an option because there might not be a match in the string. So it will return none if it didn't find it, or otherwise it will return some wrapping the index. And we know that when we have an option, we have to match on it. And it will have two cases. It will have some, which might wrap the index I of the question mark, or it might be none. If we did find a question mark, let's set a value for our query string. So we know that the query string will be everything after the question mark. So because it's an option, we wrap it in a sum, and we say that this sum will actually be a slice of the path, and we just want everything from the index of the question mark forward. But here we actually have a problem that we already solved in our getNextWord function. We remember that when we wanted to get the rest of the string, we are adding 1 to the index of the symbol that we found. The reason for this is that in the case of getNextWord, we didn't want to have the space or the new line in the rest of the string. In the case here, we do not want to have the question mark in the query string, so we can actually just add 1. And important thing to remember, when we do this math here and when we say +1 in the range for a string slice, this does not mean +1 character, this means +1 byte. But in this case, we know that at this index we have a question mark, and the question mark will be 1 byte. So this is a valid operation, and we have a valid UTF-8 string at the end. Now that we have assigned the query string, we also have to reassign our path to be everything before the question mark. So to do that, first we have to make our path mutable up here where we define it, because we want to reassign a new variable to it. And now we can actually say that path equals everything in the path before the question mark. This is everything that we need to actually split the string. And there is nothing that we have to do in the none case. If we didn't find a question mark, the path will be complete because it will only contain the path itself. But having an empty match arm like this is kind of annoying. So let's actually try to implement this in a way that will not require us to have this empty match here that is useless to us. To do that, we can define a variable. Let's say it's q for our question mark index, and we will again say path find. So now this q is an option, and we can write an if statement, and we can check if q is sum. So we will only enter this if statement if we found a question mark, and here we can say that I is actually q.unwrap, and we know that unwrap will panic and terminate the process if the option was none, but here we first check that it is sum, so this is safe. And now we can just copy our existing code and paste it here. Writing the code like this did remove the empty match arm, but it still has a lot of boilerplate, like defining this variable here and then manually unwrapping it. But as we've seen with a lot of other things so far, Rust is very keen on solving common problems. And this is a very common problem. You want to match on something and you really only care about a single variant of it, and you don't want to match on the rest of the variants. So to solve this problem, Rust has a feature that is called if-let. An if-let statement would allow us to write a normal if statement, but using pattern matching directly in the condition. Let's see how that looks. We write if followed by the let keyword. And now in here, we can actually use the same pattern matching syntax that we use in the match statement. So here we can say that we want a sum of an I, and that should be equal to path.find, and here we put our question mark. So what this if statement will do is it will look at the result from this find function. It will try to match it to the pattern that we have provided, and it will also unwrap the contents in the variable I. So now in here, if we just copy our code again and paste it inside, this will still work. But this makes the code much cleaner and reduces the overhead of unnecessary variables and unwrapping or unnecessary empty match arms. It only lets us match on the variants that we care about and completely ignore everything else. So let's delete this code, and we can see that now the code is much less and it is much nicer.